Okay, guys, what we're going to talk about in this segment is about concrete and how or what we need to do to get that concrete to stand up, right? So it's not like concrete block or a concrete masonry unit. We call them CMUs. It's made with a similar product, but that's not what we're talking about. We're talking about more as we see this foundation wall. We're in the basement of Conoy on campus, and you can see that this exterior wall, on the other side of that wall is our dock area. And you can see that, what are we in here, about 21 foot probably to the deck. So we have a 21 foot tall concrete wall. Very, very, very common in commercial construction, even in residential construction now. We're going to a lot more concrete foundations than we are the old cinder block walls, what we used to call them. Now they're CMUs. Greater strength, of course, we can control size easily with concrete. What I mean by that is we can get much thicker walls than the standard 8, 10, 12. Once, I think the biggest block I've ever seen was maybe 16 inches. It was kind of an off size. I'd never seen it before. But with concrete, we're able to do whatever the architect can dream up. At least that's what they think. And we usually don't have the engineering skills to do that design work, so we rely on third parties that supply form systems to us to do those calculations and provide us with form systems that we can execute what the plans call for with regard to concrete. One of the most common form systems, at least in this area, in my experience, is the Simons panel system. And what the Simons panel system allows us is the use of a multitude of different size panels and configurations to help us form and place the concrete. What I like about a panelized system is that we have control over sizing. We have many different sizes from 4 inches, 2-inch fillers, all the way up to 2 foot. And sometimes, dependent on the system, you can have much wider panels than that. Really, I will say this much. Size dictates the system. We're not going to use this system for anything that's much bigger than what we have over here. Maybe not even that. Certainly on one lift, we wouldn't be using this system. But we can gang these together and make huge pours. And what I mean by ganging is we put them together on the ground, and then we can pick those up and we can fly them into place and set it. Which leads me into what a second system is, and that's the gang form system. And that's something we would have seen used here when Conoy was built back in the early 80s. They would have had 16, 20-foot long panels, that full height. So when we swing something in and we place it, it's very cost effective and very efficient, because where I'm setting a 12-inch or a 14-inch panel, that's all I'm gaining every time I make that connection. In a very short amount of time, I can fly a gang panel in and I can set 16 to 20 feet right now.
Yeah.
And that's just picking it off the pile and taking it.
We can control the height of those panels.
Absolutely.
Now, in some places in construction, residential, 8-foot basement walls, 9-foot basement walls are common. So that's where we'd find a common height of the panel
Absolutely.
that you're talking about.
And you can see that, Mark, as you're saying that, that's absolutely true. You're going to see 2-foot panels, 3-foot panels, 4s, 6s, 8s, because of that. So we can kind of standardize what we're doing, because you're absolutely right. You'd want a 9-foot panel. I wouldn't want the break at the bottom, certainly because of the pressure of the concrete once you pour it, or a foot panel sitting on top of an 8-foot panel. That's a hinge point,
Right.
and that concrete will probably exploit that and you're going to have something that has a bow in your wall where the concrete pushed out.
So
So
one
that's a great point. We standardize these panels.
So we can do one continuous pour where we can. So Scott, it looks like you're able to, not only there's certain height panels, but it looks like with the system you can set up the thickness of the wall based on the
Absolutely.
system. And where do you get the thickness of the wall?
Well, first of all, we don't do anything right without consulting contract documents, our plans and specification. You're going to go to the foundation plan on the prints, and we're going to start looking for areas that we're going to be constructing in and seeing what the footing looks like, and then what kind of steel we have coming out of the footing, doweling into this wall, and we're going to get a wall thickness from those drawings. Another place we can go to is specification, into the spec book. And you're going to go into 0300 and 03000 rather, and that's the concrete, the CSI divisions. And in there, it's going to tell me everything from, sometimes they'll designate what form system they want, because some form systems have skins that facilitate almost a burnished look. The first time I'd seen it was at a museum down in Arkansas, in Bentonville. And when I walked in, the entire museum was wood and concrete. One of the most beautiful structures I've ever been in. And the concrete was, it looked like I'd taken 4,000 grit diamond stone and polished a piece of granite. It looked like a piece of polished granite, but it was concrete. Wow. It was beautiful. And I really racked my brains, and I was with a good friend of mine who was a project manager for 30, 40 years, and neither one of us had ever seen this. If we did something like that, we're burning a finish into a floor with a trowel machine that you can almost shave in that finish, but I'd never seen it in vertical construction. And I'm racking my brains, so that sent me to go research. How did they do that? It would not be time efficient to have somebody on a grinder polishing vertical concrete walls in a structure that size. But what it is the skin is made with a polymer. And actually the concrete laying into that polymer creates that. So when they use the form release, doesn't mess with that sheen. Actually, I'm sure it has something to do with helping it. And then once you pull the panel off, it doesn't take very much to buff out that polished nature. Gorgeous, gorgeous. But that's what the kind of technology we're seeing today with concrete. What can we do? What is the finish? Do we have systems that are quick and efficient to set? These are labor intensive, but on an 8-foot foundation wall, you can fly with these things. And I think you're going to see, probably you've, Mark, had a lot of experience with Simon's panels, Burke panels, same type of system. It's a metal frame with a wood skin. We use wedge pins to join these together. And all a wedge pin is, it'd be two, since we're dealing with steel and not wood, we're not going to be driving a lot of nails into a steel frame, right? So what if we had to bolt them together? That's typically what we do with two pieces of steel, right? We'd take a bolt, a washer and a nut, and
very time consuming.
You know, it's going to tell me, Simon's is going to tell me that I at least have to have a tie 6 inches from the top, 6 inches up from the bottom, and then every 1 to 2 feet in there, dependent on the thickness of the wall, to how many wall ties I got to use.
And probably the height of the wall.
Absolutely.
Because of loads on the wall. So the tie is this piece here.
Right. So if you wouldn't mind reaching in there and show them one, it's just a flat piece of metal stock that has some notches in them. And those notches, if we used this, we can shift the holes for a 6-inch wall, or we can come to the outsides. And this, if we set this in and we put the pins in and tighten it all down, we're going to end up with an 8-inch wall. That could be a 10, that could be a 12, 14, 16, 18. The thickest concrete wall I've ever poured was 8.5 feet thick.
So this stays in the concrete?
Yes, it does.
Okay. So then I see that the tie, if my pour is from form to form, I've got some part of the tie that you've used a wedge pin that is sticking outside of the wall. What happens after my pour?
So look where this is notched. Okay, if you measure that dimension, you're going to have 8 inches in there. So what we do is after we have allowed the concrete to set up and cure for a pre-described amount of time found in specifications, going to tell us, before we can come back in and strip these panels off. And once we strip the panels off, all you're going to see is a concrete wall with a pattern of the ends of these ties sticking out. Well, that notch is there so we can come in, take a hammer, and we can bend that over, bend it back and forth, and it'll snap right off. So it's called a snap tie, even though it's flat. We have another type of snap tie, which is a loop tie. It's a round piece of stock, so it's a rod stock instead of flat stock like this. And you just use a drift pin, you come in, you slide it through the loop, you spin it, it snaps it off, you pull the loop out, and then you're left with a hole. And then all you have to do is mix a little bagged concrete, mortar mix, and then you fill the holes, and then usually it's rubbed.
So this has not got much to do with the strength of the concrete. It's what holds the two forms together.
Exactly.
When the wet concrete goes in.
It's about the strength of our form system.
Got it.
We can't just stick 2 walls up and then just support them with bracing to the outside and expect those to stay. You got to understand, concrete, if you think dirt's heavy, and dirt can range from, I think it's like 135, 155 pounds per cubic foot. You know, concrete's no different. We have some very heavy, because we're using aggregates, so we're using a larger aggregate, depending on what the concrete mix calls for. It could be 53s, which, 3/4 inch stone, could be 2s, it could be whatever. 2s is up to 2 inches. Then we have fine aggregates, we've got sand in there, and then we've got cement,
And water.
and water, and 4 main ingredients to concrete, and then there's just tons of additives you can put. But my point is that you can have concrete weighing 5,000, 6,000 pounds per cubic yard, and maybe more.
Yeah.
So when we pour this in and you put a cubic yard at the bottom of this form over 8 foot long a wall, you might have, this much up the wall, but the pressure at the bottom is all that weight pushing out. Now, what if you're dropping that down 20, 30 foot of wall? By the time it hits the bottom, we've got to have something in the wall between the two sides of the form system that's going to keep it from spreading.
Sure.
And that's what our wall ties do. It keeps the wall forms from expanding out. Or more often than not, it's this. The bottom of the form will give way, you'll get one to snap, and then you've got a big problem. Because once that concrete starts, it'll just open this stuff up. It's like dominoes, pop, 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 pop,
Yep.
pop, pop. And I've watched 14 yards of concrete roll towards me and then down onto the slab. And probably the largest wall pour I was ever responsible for, we were pouring 44-foot tall, 22-inch thick concrete walls. It was a big nitrification tank at Eli Lilly Corporation. It's where they would take wastewater and clean it with a certain kind of bacterial process, right? It was 14.7 million gallon tank. Huge. The slab pour was almost 5,000 yard of concrete. Wow. We ran constantly, 3 pump trucks, 14 hours. The wall pour was about 1,100 yard wall pour. That's huge when it's walls.
That's a giant pour.
And it busted and we lost 15 yards, and actually the whole wall that was poured to that point had to come out.
So are there other ways that we can form up concrete?
Yeah, there's a lot of different ways. We can loose leaf, we can use plywood
Okay.
I've seen people pull up, we can, like for footings, and sometimes if we're pouring a slab monolithically, we can pour right into the dirt. We don't even need a form system on footings, really.
Just use the excavation as
Just
the
use the
forms.
excavation as your form, especially if you're in a good, stable substrate. If you're in clay, that's wonderful. Absolutely. But typically, when it's above ground, we've got to have it in some sort of system. And these systems go together quite nicely. We have a few different things that we have to keep in mind when we're doing it. If we have an 8-inch wall here, we have a pre-described size of inside corners, outsides, how we make them. This is a 6x6 inside corner. I'll take it off here for you, spin it around. You can see it makes an inside corner. So if I have 6 inches, this is a 6x6 corner, and I've got 8 inches of concrete out here, I don't have pre-made outside corners. I actually have to use panels in these systems to make that outside of the corner. So all I have to do is a little bit of arithmetic. If I know the thickness of my wall and I know the size, the width of my inside corner, I just add those two dimensions together until I hit the right thing. So if I have an 8-inch wall, I'm going to add that to 6 inches, which means that my two outside form panels have to be 14 inches because 8 plus 6 is 14. So we take a piece of angle iron that's slotted to key in our wedge pins, and we just button that up. You can see how he's putting that in there, and then we'd run wedge pins. And these wedge pins work as simply as that goes through the two pieces of steel, and then you drive in this, and as this comes down the webbing on the frame, because it's called a friction fit, you beat it in and it actually cinches up the two pieces of metal that you're bringing together. It's a pretty slick process and it's very quick. Like we were saying, you bolt stuff up. We've gone to these wedge pins. Now we do have pause at a certain size. We will start putting bolts top, bottom, maybe in the middle when we've ganged these panels up. I want something a little more substantial than just the wedge pin.
Sure. So it all depends on, again, height, thickness.
So once we understand how we need to make our corners, the rest of it is just putting together a puzzle, really. The only thing that we have to understand about these form systems is that whatever panel we use on the outside, we have to use on the inside. Because with these Simons, we're putting a vertical row of our wall ties every joint. So if we're going every 2 foot, for us to facilitate that tie going across and locking us in place, I have to use the same size panels.
So if I had a 2-foot panel here, you can't use two 1-foot panels here because there's nothing to tie in
Right,
between.
because in the middle of that 2-foot panel where you've made it using two 1-foot, you have a hinge point. And concrete always exploits those hinge points.
Got it.
If you don't have a tie, you better put pencil rod, which is a 1/4-inch thick piece of rod stock that you use cat heads, and you have a puller. So you can actually, where you don't have a tie or aren't able to use it, because every once in a while you'll do things where you have to kind of ad-lib. Mm-hmm. We have some materials and some hardware that we use in those instances, but that's only if we can't get the way it's supposed to be built, because we don't want to rely on secondary hardware instead of this.
Sure.
Because this is designed for that wall pour.
Now, Scott, I've seen some wall ties that have like little half moons cut out of it, and it looks like they drop their rebar in there.
Yep.
That's the reinforcing steel
Absolutely.
that runs horizontally
Yep.
through their concrete, and they actually use the wall tie as like a carriage
Yep.
for those layers of rebar so it doesn't all sink to the bottom with the weight of the concrete.
That's a good point, because something that does, especially when you think about that wall pour I was doing at Eli Lilly, that concrete was falling. Now we had chutes and we were getting about halfway down, but that concrete on the first 3 or 4 lifts, that was falling a good distance and rattling down through. So you got to remember, it's gravel with water, sand, and cement.
Hitting the rebar.
Right, it's hitting and it's separating. So that rock is just constantly hitting your horizontal rebar in the wall. And like you said, it will tend to get it to start settling, because all we've done with the rebar is used some wire to tie that.
And a wall could have dozens and dozens of row of rebar crisscrossed.
Oh,
so
yeah.
it kind of acts like a screening system if you're not careful.
Absolutely.
So how do you get it? If you've got it mixed in the truck, it comes to your site, it meets spec, you drop it down through dozens of bars of rebar, and it's starting to separate at towards the bottom. How do we accomplish
We have
fixing
to
that?
Yeah, we have to reconsolidate the concrete. When we get it down in the form, we cannot leave that separated, because what happens is when you pull the form off, gravel will just drop out. I've seen in those that big pour, that tank pour out at Lily's, we had areas where we could pull a form off and literally you could drive an MG through it, which is a little sports car.
Yeah.
Not very big at all. Mark and I'd have to shoehorn ourselves to get in. But that's how big the hole was where it was just gravel. So the concrete had separated so much that it really didn't even look like it was concrete. It looked like it was just a gravel pocket inside a concrete wall.
Sure.
Just fell out. So what happens? Well, that chunk of wall came down and we re-poured it. So how don't we end up with those, what we call honeycomb is a bad situation in concrete. It's not as bad as gravel falling out, but you have voids in the concrete where the aggregate didn't reincorporate back together. A couple different ways we can do that. Primary way is vibration.
Okay.
So whether that's coming from inside the wall or we're hooking these big U-shaped vibrators to the stiff backs on the form system, and it just shakes in place. And as all that comes back down, it's reconsolidating. Now, that has its pros and cons, but when you couple it with utilizing vibrators that we have one upstairs, we'll have.
Like more of the hose style that they
Right,
drop
so it's
down.
a hose and it has a big long steel head on it, and we fish that down between our rebar into the wall. We dip into the concrete. We don't stay there, and we can over-consolidate, which just turns around and re-separates it, right? So
Right.
you bring it together, and then you can re-separate it again if you over-consolidate the concrete. So, you're going to fish that down in, and here's one thing. We never fill concrete walls all the way to the top first time. What we have to do, and once again, we find this in specification, that we pour lifts. So if we're pouring a big, huge rectangular foundation, it's just a big box, right?
Right.
We start in one place, and we're only going to bring up whatever the architect or engineers tells us we can bring up. Typically, we're going to bring up 2 foot of concrete. That's all the way around that. And then as I've consolidated that by fishing down a concrete vibrator, we're going to run that around, and as we're consolidating around, here comes lift number 2. We'll bring up another 2 foot. Now, consolidating there, I have to go through that lift down into the first lift.
Because you're trying to blend the two lifts
Blend those
together.
two together, because the first concrete's already been in the form and it's already setting up.
Right.
We may be in, we may have 20 trucks we've already poured out.
Right.
So we've got fresh concrete coming in all the time as we're bringing up the wall. So we have to dip between the lifts so we can consolidate that, because we don't want to end up with what we call a cold joint. And a cold joint is where the two lifts did not reconsolidate together. What happens is it's just like two pieces of concrete. Now we have a place for moisture to come through.
So you get that cold joint. I've also heard it referred to as a load line.
Yep.
So you get that line in the wall, which is moisture, weak spot in the wall, and
Absolutely.
you're basically building a block wall, but you did it out of concrete unintentionally.
So if you've got that down at the bottom of a 44 square or tall wall, 14.7 million gallons, you think about that hairline crack down here or that cold joint. What's going to happen? All of that head pressure of those millions and millions of gallons are going to start pushing that water through the wall. And let me tell you something, it's disheartening because when they filled that tank up, we saw everywhere we had a cold joint. Because nothing is ever done perfectly when it comes to concrete. We can get real close, but always something's going to come back to bite you.
Sure.
Now, we did have some materials, high pressure injection of an epoxy resin that actually filled that. We had to do that. It's a very expensive process, but there are ways to fix this when you get, I mean, my God, if we'd have had to cut out every chunk of wall that had some sort of problem with it, you couldn't be in business.
Sure.